And for this problem, again, as I read, so Shaq's free throws, that looks like they're talking about the claim. So that would be my P. And then I notice that he's made 26 out of 39. So that's my P hat value, which is 0.6 repeating. So I'm going to round it to 667. And they gave me an alpha level of 0.05. So now, if I'm checking to see whether or not evidence that he's significantly improved, what that would tell me is that my null hypothesis is no improvement. In other words, he's still shooting at 53.3%, but the alternative is that he's gotten better. So Shaq shoots 53.3% free throw, and this one would be greater and again, dependent upon which version I'm doing, I'm going to go with one prop z test, and then I'll go do z interval second just so you can see it. So my conditions, SRS, well, here's the thing. It doesn't say, as a matter of fact, it says in his first few games. So that doesn't seem like that's an SRS. This is questionable. Although we might be able to consider them to be, I don't know, can we consider his first few games to be representative of all games? So I would put a proceed with caution on this. And we will assume our independence rule is fitting. Remember, our sample size was the 39. And then since I'm doing z-test, then I want to use the popo to check for normality. So for a normality check, I'm doing 39 times 0.533 using the popo, and 39 times 467, and making sure that those both are greater than or equal to 10. And so then I'm ready to actually do my calculation. Remember, I'm going to need a bell for this also. So I'm going to have z equals, and I need my p hat, which was 0.667, minus the po over the standard deviation. But remember, since we're doing z-test, then it uses the popo inside that standard deviation. So you'll have to remember for the proportions, it's always about what goes inside the standard deviation and what do we use for the normality check, because they always match. So for a z-test, it's the popo for both, and for z-interval, it's p hat for both. And then that's actually a pretty good way, I always think, to remember. And so I get 1.677, and when I draw the picture of it, of course that places it over here, leaving out some details because I'm kind of squished for room. And I would shade to the right, and since this is a one-sided test, I'm not going to need to double. And of course I can use normal CDF to go find this area. We've been doing that since chapter 2. And I get an area, which is my corresponding p-value, of 0.0467. And now comparing that to alpha, since it's less I will have to reject. And again, you're going to write out your entire big run-on sentence / 2 sentences about why you're rejecting. All right, so let's look at the interval way.